Okay, hi. I'm just doing this mini lesson to talk about our layout of an Arduino board. An Arduino is called a microcontroller, and it's not a computer, it's a microcontroller. I thought we'd go over what it looks like and what the different parts are, okay? So just a quick overview, okay? We have this part, is the USB port for your Arduino. That's where you plug to your computer, right? Then we have, what else do we have here? You will notice that we have, just a quick overview, we have a whole bunch of pins here where you can plug in wires, and we have a whole bunch of pins here where you can plug in wires, right? We have some LEDs, okay? So over here, we have, these are the transmit and receive LEDs. So basically, when you plug this to your computer and you're downloading a program, you'll see these LEDs flashing. Over here is another LED that, over here, that you can use to light up and program, and it'll do all kinds of things. And then over here you have an LED, which is just to let you know that it's receiving power, right? To know that it's working. Okay, now let's look at the pins. So let's look at, first of all, the power pins, okay? So right here we have a ground pin, okay? And over here we also have two more ground pins. And those ground pins are the same on both sides, okay? So these ground pins are the exact same as that ground pin. Now, you also have over here, these pins are so small, but anyway, you have 3V3 and 5V. Those are constant voltage pins, okay? And you have two. There's a 3.3 volts pin and there's a 5 volt pin. Okay, so those are constantly providing electricity. And if you hook this power pin, this 5 volt pin, for example, through a resistor and an LED to the ground, it'll always stay on. Okay, what are some more pins? Let's look at these pins over here, okay? Those pins are digital pins, and we'll talk about what that means in a second, but you have pins from 0 to 13. Okay, so let's label that. So we'll say digital input output pins, okay, I/O pins. What does that mean? They can receive information or they can send information. So I can hook, for example, let's say pin 10, okay? If I take pin 10, I can hook that up to a wire that goes to a light and then to the ground, and make that pin turn on and off the light by giving it electricity or not. I can also hook pin 10 up to like something like a sensor. So that sensor, let's say it's a light sensor. When that sensor notices that there is light, it can the sensor sends a signal into pin 10 to the computer and to the microcontroller, and then the microcontroller can do something based on that sensor. So basically this pin can send electricity out to power something like a light or a motor, or it can receive electricity so that the microcontroller can use this to make decisions or to carry out a program. Now you'll notice that some of these pins, they have a little squiggle. So pin 3, pin 5, pin 6. If you look at those 2, 3, 5, 6, 9, 10, 11, if you look at them, let's say look at 3, you'll see that the 3 has a little squiggle in front of it, okay? That's important, but we'll talk about that later, but it's worth noting so you see it. Lastly, these two pins I generally avoid using unless I need to, because those pins, actually they can be digital pins just like the rest, but let's do okay, those are transmit and receive pins. So, for example, if you want to hook up your Arduino to a Bluetooth, chip that can send information to your phone or receive information or whatever, you would hook it up through those. Okay, so those are the digital pins. Now, what does digital mean? Okay, digital means that basically each one of those pins, when you give it or receive information, it is really only sending information which is either 0 volts, so nothing, or a full 5 volts. So if I want to use these pins to turn on a light, in theory, I can only give full power and turn on the light full blast with 5 volts, or I can turn the pin off and turn off the light. But I can't turn it on to provide 2.5 volts in the middle. It's either all on or all off. Likewise, when it's receiving information, when it's an input, okay, it can only receive, it'll only notice whether something is giving 0 volts or whether it's giving, something close to 5 volts. If it's getting something like 2 volts or 3 volts, and like 2 volts of energy are going into the pin, it's not going to really know what to do, and it's going to probably make mistakes. So that's what digital means. It's on or off. It's full power or no power. Last topic here, we're going to talk about, let's do this in a pretty color. We haven't really done a lot of green. So last topic we're going to do here are these pins over here. And these pins are very similar. So these pins are very similar to these pins. Okay, but they are analog. You can see the writing. They are analog in. Okay, so what does that mean? It means that when I hook up a sensor to this, one of these pins, okay, that pin will actually be able to measure a value of voltage anywhere between 0 and 5 volts. Okay, and it'll actually measure in between. Okay, so you could have a sensor that doesn't just tell you, like a light sensor that doesn't just tell you, if it's this much light, turn on a light. If it's this much light, turn off your light. You could actually have a sensor hooked up to this one of these analog pins, which will allow the microcontroller to, for example, say, okay, if it's 20% of the light, if I notice only 20% of the light, well, then increase the light a little bit. And if I notice, less light, then make the room even brighter with your light bulb or whatever. So it can measure 1 volt or 1.5 volt or 2 volts. It can measure all those in between, whereas these digital pins cannot. It's either or. Okay, so that's a quick overview. These are the most important pins that I use generally. The last thing I'm going to say is this port, okay, that is a power jack. Okay, what does that mean? It means that normally when I use my Arduino board, I hook it up to the computer and I can program it, and the computer is giving it energy through this port. But what happens, for example, if I want to create a little toy car or a robot that moves around the room? Well, I don't want to have a wire going to my computer the whole way while my computer's on the desk. I want to be able to hook this thing up to a battery. And this is the way to do it. So this is basically, it accepts electricity, and you can hook it up to a battery. A 9-volt battery works well. And it'll power your Arduino, and you could have it running on its own. Or if you're in a room that doesn't have a computer and you don't have a computer nearby, but you have a power jack, you can plug this into the wall directly, right? To your outlet with the 2 slots. Let's try and do that faster before this disappears, right? Anyway, you get the idea. Isn't that a cool tool? Kind of disappears. I'm having fun. Okay, so that's the overall idea here. I hope that helps. Bye.